Okay, hello again. So in here, we'll start now with part number 21, which is computing integrals using substitution method. In the first part, we'll solve exercises from 5 to 14. These exercises, you'll find them in page 376. Okay, then we'll move directly to part 22, which is the same part exactly, computing integrals using substitution, but we'll continue with the questions from 17 to 26 in the same page. Okay, so starting with the first part, questions 15 to 14. So let's see how we can solve the question or how we can use the substitution method. Now, the concept of the substitution method that if you have a product of two functions or division between two functions and one of the functions is derivative or part of the derivative of the other one. So in this case, you can use the substitution method by substituting this function, which is the function that has its derivative or part of its derivative. You can find it in the question. So in here, for example, let's start with the question 5. So in here we have x cubed, we have square root of x to the power 4 plus 3. Now for x to the power 4 plus 3 for this part of the function, okay. So in here the derivative of x to the power 4 plus 3 is equal to 3x cubed plus 0, okay. Now for 3x cubed we can find that x cubed does exist over here. So for this function or this part, which is x to the power 4 plus 3, we can find its derivative or part of its derivative. So directly, my substitution, it will be x to the power 4 plus 3. This is going to be the easiest method to know what part I must substitute in the question. So in here, I will say u is equal to, in here, x to the power 4, okay, so plus 3. Then I can say that du is equal to 4x cubed dx. Then I will solve this equation for dx. So du over 4x cubed equal to dx. But I press a button and everything was erased. So again, we will say u is equal to x to the power 4 plus 3, then du equal to 4x cubed dx, then du over 4x cubed equal to dx. So now let's substitute. So the integration, so in here we have x cubed, then we have square root of u, since we substituted this expression as u. So in here, instead of dx, I will write du over 4x cubed. Now, x cubed with x cubed eliminated. We have 1 over 4 outside, multiplied by the integration of u to the power 1 over 2 du. Now, 1 over 4 multiplied by the integration of u to the power 1 over 2. So this is equal to u to the power 1 over 2 plus 1, which is 2 over 2. So u to the power 3 over 2, sorry, okay, over 3 over 2 plus c. Let's just simplify this. So this is going to be equal to, after flipping this, this is going to be 2 over 4 multiplied by 3, okay, u to the power 3 over 2 plus c. Okay, now 2 with 4 we have 2, so 1 over 6, 1 over 6 multiplied by u to the power 3 over 2. We must write the x's again. So in here, instead of u, I'll put the expression that I have substituted, which is x to the power 4 plus 3. So this is going to be x to the power 4 plus 3 plus 3 in here. Okay, that's it. So then again, this is plus 3 to the power 3 over 2 plus c. And that's it. This is the end of the question. If you would like to make sure that your answer is correct, you can find the derivative of this function. If it's equal to this value exactly, that means your answer is correct 100%. Okay, so in here, let's say if we have a question 6. So the integration of 1 plus 10x, okay, dx. Now the derivative of the expression inside in here, this is equal to 1, the derivative of 1 is 0, then plus 10x, so 10x, the derivative of 10x is 10 only. So in here we have 10 multiplied by 1. In here we don't have any constant, which means in here it's 1 only. So in here we can say that the derivative of this function does exist outside, which is constant. Okay, so we can say in here the integration of square root of 1 plus 10x dx, this is equal to, and here we can say I can substitute u equal to 1 plus 10x. So after that, du, it will be equal to 10 dx. Okay, so now solve for dx. Dx is equal to du over 10. So now all I have to do is just substituting square root of 1 or u, because we already substitute that, multiplied by, instead of dx, I will write du over 10. Now in here, this is the integration of u to the power 1 over 2 and the 1 over 10 outside, and in here du. So this is going to be 1 over 10 multiplied by u to the power, uh, in here we said 3 over 2 over 3 over 2. Okay, plus c. So now flip these and simplify directly. So after flipping, it will be 2 over 3, 2 with 10. So that means I have 1 over 3 multiplied by 5, which is 15. Okay, so now I have u to the power 3 over 2. Let's write back in here the 1 plus 10x to the power 3 over 2 plus c. Right. That's it. Okay, that's it. So let's see how we can solve also these questions. Question 7, question 8. So starting with the question 7. In here, the derivative for what? I'm looking for a function that I can find its derivative or part of its derivative. Okay, so in here, if we substitute the square root of cosine, the derivative of the square root of cosine x is the derivative of what inside the root, which is minus sine x over 2 multiplied by the same root, cosine x. So in here we can find that sine x over square root of cosine x does exist. So part of its derivative for square root of cosine x does exist. So I will say u equal to square root of cosine x dx. No, dx is not here. After writing the derivative, I will write dx. Okay. Okay, so eraser. Okay, so now that's it. So find the derivative. Du is equal to the derivative of what inside? We said minus sine x divided by square root of 2 multiplied by square root of cosine x. Okay, dx. Now, after that, solving for dx, so it will be 2 square root of cosine x divided by minus sine x du is equal to dx. So now all I have to do is just substituting. So sine x divided by u dot, and here we have dot 2 square root of cosine x divided by minus sine x. So sine with sine, I have only minus 1 over here, and in here du4. Okay, instead of square root of cosine x, I can put u as well. So this is going to be the 2 outside or the minus 2 outside, integration of. So in here we have, okay, so instead of square root of cosine x, we said we can put u again, or divided by u, okay, du. Okay, now u with u 1, okay, so this is equal to what? This is equal to minus 2 multiplied by the integration of 1, this is equal to u plus c. Now put this again. Now minus 2 multiplied by square root of cosine x instead of u plus c. Now you can say that in here we can find the derivative of that. The derivative of that, it will be, for just making sure to check if your solution is correct or not, minus 2 multiplied by the derivative of what inside the root. This is minus sine x over 2 square root of cosine x. Okay, so in here the minus with minus positive, 2 with 2 eliminated, so that will leave me with sine x over square root of cosine x. So this is check. Okay, so this is check your solution. So you can check your solution by finding the derivative. Okay, so moving to the next part, which is question 8. So in here for question 8, we are looking for function that we can find its derivative or part of its derivative. Okay, so in here, sine cubed x, and we have cosine x dx. Now the derivative of cosine is equal to minus sine, and the derivative of sine is equal to cosine. So we can find the derivative of sine and we can find the derivative of cosine. So let's substitute the sine, for example. Now when you're actually solving using substitution, it's trials. So sometimes it's not going to work from the first trial. Sometimes you need 2 trials. Sometimes you need 3 trials. So whatever. So sine x, okay, is equal to u, for example. So in here, du is equal to cosine x dx. So now dividing by cosine, so du over cosine x equal to dx. So now I will say if I have this, so let's substitute u to the power 3. Instead of cosine, I'll write cosine the same thing. Okay, dot du over cosine x. So cosine with cosine eliminated, right? So now all I have to do is just finding the integration of u cubed. This is u to the power 4 divided by 4 plus c. Then I'll put my value back again. So this is sine to the power 4 x divided by 4 plus c. That's it. This is the end of question 8. Okay, let's see the next question. So here we have the integration of t squared multiplied by cosine t cubed. Okay, so in here we can say that we don't have the derivative of cosine, we don't have minus sine or sine. But in here we have the derivative of t cubed. The derivative of t cubed is equal to 3t squared, which is in here we have t squared. So my substitution over here, it will be u is equal to t cubed. So directly du is equal to 3t squared dt. Okay, so and here I will solve for dt. So du over 3t squared is equal to dt. Okay, so now starting with the substitution, so this is t squared cosine u dot in here du over 3t square. Okay, so now t squared with t squared eliminated. The integration of cosine is equal to sine. So 1 over 3 sine u plus c. So now 1 over 3 sine. I'll put back my value, which is t to the power 3. So this is t to the power 3. Okay, plus c. That's it. This is my final answer. Okay, move to question 10. Any question 10. What function we have its derivative or part of its derivative. Now for cosine t plus 3, the derivative for this expression is minus sine. So the derivative of cosine is minus sine. Okay, so we can find sine x or sine t over here. So the derivative of this function does exist or part of it. So in here my substitution, obviously it will be cosine t plus 3 without taking 3 over 4. Okay, so du is equal to minus sine t dx or dt in here. Okay, so dt or du over minus sine t is equal to dt. So now let's substitute again. So sine t multiplied by u to the power 3 over 4, okay, multiplied by du over minus sine t. In here, sine with sine, we have minus 1 outside. So the integration of u to the power 3 over 4 is u to the power 3 over 4 plus 1. 3 over 4 plus 1, which is 3 over 4 plus 4 over 4, which is u to the power 7 over 4 divided by 7. Flip the 4, so it will be upward. So now plus c. Now write your assumption back. So minus 4 over 7 multiplied by in here cosine t plus 3 to the power 7 over 4 and plus c. That's it. This is my answer. So let's move to question 11 directly. So this is question 11. So in here, the derivative of x squared plus 1, this expression is 2x. Okay, we can find x. So part of this function we can find it, or part of this function we can find its derivative. Part of its derivative. Okay, so in here, my substitution, it will be, or my assumption, it will be u is equal to x squared plus 1. So now du is equal to 2x dx. Okay, now dx is equal to du over 2x. So directly I will go to the integration of x e to the power u over here, okay, du over 2x. X with x eliminated. So in here the integration of e to the power u, this is equal to 1 over 2 e to the power u divided by 1. So no need for writing that plus c. So now e to the power, let's write the assumption back, x squared plus 1 divided by 2 plus c. That's it. Okay, so let's move to the next question. Now the derivative of e to the power x plus 4 is e to the power x, which we can find it over here. So my assumption, obviously, it will be what? It will be e to the power x plus 4. So u is equal to e to the power x plus 4. So over here, du is equal to e to the power x dx. Okay, so now in here du over e to the power x equal to dx. Okay, so now directly I'll start by substitution. So e to the power x, and here square root of u multiplied by du over e to the power x. So e to the power x with e to the power x eliminated. Okay, so now square root of u, which is the integration of u to the power 1 over 2 du. This is equal to u to the power 1 over 2 plus 1, which is 2 over 2. So this is 3 over 2 over 3, and flip the 2 plus c. So now let's write our assumption back. 2 over 3. So in here e to the power x plus 4 to the power 3 over 2 plus. That's it. Okay, moving to questions 13 and 14. So question 13, let's start with it. So the derivative of square root of x is 1 over 2 multiplied by square root of x. By the way, I have uploaded the derivative sheet. Okay, so if you would like to see the sheet to remember the rules for for finding the derivative and the rules that we have written in the class for finding the integration, you can find the PDF file which is included by all of these rules to find the derivatives and to find the integration for different functions in our group. So I'll try to add them also in the description of this video. So in here, u is equal to square root of x. So now du is equal to 1 over 2 times square root of x dx. So now du multiplied by 2 square root of x is equal to dx. So now all we have to do is just start with the substitution. So e to the power u over square root of x dot 2 square root of x du. So now this with this eliminated. So the integration of 2 e to the power u, which is 2 e to the power u, sorry, divided by 1. No need for writing the 1. So in here, let's write the assumption back to e to the power square root of x plus c. That's it. This is my answer. Okay, so now let's see how we can solve question 14. Now the derivative of 1 over x is minus 1 multiplied by the derivative of the denominator, which is 1, divided by the denominator square, which is minus 1 over x square. We can find 1 over x square over here. So part of the derivative of 1 over x does exist. So in here I will say u is equal to 1 over x. We cannot take cosine because in here we don't have the sign, for example, or minus sign. So directly I'll say du is equal to minus 1, okay, multiplied by 1 divided by x square dx. So over here it will be x square minus x square du equal to dx. Then I'll start the substitution. Cosine u divided by x square multiplied by minus x. This is x square, okay, du. So x square with x square we have minus. So the integration of cosine is sine, okay, and we have the minus. So sine u plus c. Then I'll write my assumption back. Sine 1 over x plus. Okay, now the end of this part, which is we have these two questions. So let's start with the first one. Okay, question 15. Now the derivative of len x, the derivative of what inside the len, which is 1, over what inside the len, which is x. So we can find the derivative or part of its derivative, which is 1 over x. So in here, I will say u is equal to len x. There is no need for taking the square root. I have just to take the len x. So du is equal to 1 over x dx. So now after that, we have du multiplied by x. Okay, this is equal to dx. Okay, so now I'll start with my substitution. Square root of u over x multiplied by x du, and x with x eliminated. The integration of u is u to the power 3 over 2 divided by 3, and that's the 2. Okay, then plus c. So all I have to do is just write my assumption back. Len x to the power 3 over 2 divided by 3, then a plus. That's it. This is for question 15. So let's see how we can solve the last equation, which is equation 16. In here, the derivative of tan is equal to 6 squared, so we can find its derivative. So u is equal to tan x. Okay, so now du is equal to sec square x dx. Okay, so now du over sec square x is equal to dx. Okay, so now I'll start my substitution. Sec square x square root of u dot du over sec square x. Okay, so now square root of u, so the integration of that u to the power 3 over 2 over 3, and this is the 2 plus c. Now just write your assumption back. So 2 multiplied by, in here, tan x to the power 3 over 2 divided by 3, then plus. That's it. This is the end of part 1, or this is the end of part 21, okay, of finding the integration by using the substitution method. So next, inshallah, we'll continue with the substitution method, but we will solve the questions from 17 until question 26. So see you then, inshallah.